This is problem 30.31, and it says that we have a circular coil enclosing an area of 100 centimeters squared, so A is equal to 100 centimeters squared, made up of 200 turns of copper wire, as shown here. So these are the 200 turns. The wire making up the coil itself has no resistance, but the ends of the wire are connected across a 5 ohm resistor right here. So R is equal to 5 ohms, and this is forming a closed circuit. Initially, we have B is equal to 1.1 Tesla going perpendicularly upwards. They then say that the direction of the magnetic field switches, so it still has the same magnitude, but then it points downwards. It takes 0.1 seconds to do this switch. You're then asked to figure out what the average current is during this switching. So we don't have a change in the magnitude of the magnetic field. We also don't have a change in terms of like this area that's being enclosed, but we do have a change in the angle, theta, that is defined as being the angle between B and A, right? So if we have the area vector, let's say it's pointing up like this, well, all of a sudden, when B switches directions, they're 180 degrees apart instead of being 0 degrees apart. And that is going to have an impact on our induced current, right? So what we see is that the magnitude of the induced EMF is equal to N, and then we have to measure how does the flux change over this time interval. And we know that we have delta, that the change in flux here is going to be equal to N B A delta cosine of theta, because it's that angle that's changing, not B, not A, but the angle. This is all divided by delta T. So what we see is that we have E is equal to N is 200 times 1.1 Tesla times, and then A is 100 centimeters squared, so it's 100 times 10 to the negative 4 meters squared, and then it's going to be cosine of 180 degrees minus cosine of 0 degrees, right? Because like that's the swap that's happening with that magnetic field. So then we have E is just equal to 44 volts. And that's it. We just plug in the numbers. We want to know like what is the average current though. And so we say that I is equal to E divided by the resistance, and that's just going to be 44 volts divided by 5 ohms, and that's going to give us 8.8 amps. And that is it for this problem.